Hello, my name is Aybora Köksal and today I am going to talk about our research paper, Effect of Annotation Errors on Drone Detection with YOLOv3. This research is done by me, Kutalmış İnce, and Aydın Alatan in Center for Image Analysis of Middle East Technical University. Before I start, please have a look at my outline. The main aims of this study are understanding the effects of annotation errors in a training set for object detection and automatically detecting and correcting annotation errors in any tracking dataset with a ground truth. For nearly a year, we were actually working on UAV detection by fine-tuning YOLOv3 with different datasets. It generally works fine, but there are some bad results. When we looked them visually, we saw different kind of annotation errors in the incorrect results. Then we wondered, if we correct the errors in the training set, will the results get better in test sets or not? Well, we should firstly train YOLOv3 using anti-UAV dataset. Only thermal data used in this work. Random 70 of the videos used for training, and the rest of them are left for validation at the end. Before I show you the results, let me define the metrics we have used in this work. Hit rate is number of hits in all of positive samples, where hit is defined as frames whose IOU is bigger than 0.5. Meanwhile, false alarm per minute, where false alarm defined as frames whose IOU is exactly 0. Tracking accuracy actually is the one defined by Anti-UAV Challenge Committee. On the other hand, modified tracking accuracy is defined by us. Since we are working with a detector, our network can give more than one detection in a frame. In order to penalize additional false alarms, we can use modified tracking accuracy. Let me explain modified tracking accuracy with a specific YOLOv3 output on the figure. There is a correct drone on the left, meanwhile right ones are false alarms. Tracking accuracy gives IOU for this frame without any punishment, but modified tracking accuracy causes denominator to be 3 as number of detections, and the score gets smaller. Now, let's have a look at the results. When we fixed objectness threshold to 0.5, we get 97.5 hit rate, whereas network is 2.4 false alarms per minute. Tracking accuracy and modified tracking accuracy is close to each other in this case, around 73.5%. Although the results of the training are quite well, we have found there exist some annotation errors in the dataset, like the ones you can see here. So, in order to measure the effect of the annotation errors, we have decided to make some experiments. We have tried to simulate different types of annotation errors. The first type is an additional boxes, where there is an extra box on a frame and it does not contain a target. There are two types of additional boxes tried in the research. First one is temporarily consistent one, where a random additional box is selected in one frame and that box is tracked through consecutive frames. The other is the independent one, where the additional boxes are selected completely random in each frame with a probability p. This p is mostly 25% or 50% in our experiments. The second type is missing boxes, where there is an object in a frame but the annotation is missing. This again have two types. Temporarily consistent one has missing boxes in consecutive frames, meanwhile in a completely random case, each frame can have missing boxes with a probability of p. The last type is shifted boxes. In this case, a Gaussian noise is added to the center of each box. It has zero mean and a defined variance. Meanwhile, the sizes of the boxes stay same. After defining the types of the annotation errors, let's have a look at the results. If you look these results carefully, you can see both false alarm and hit rate increases or decreases together for the most of the time. Actually, this is because the objectness score changes. When the missing box is introduced, the network tends to give the less detection, hence lower objectness scores. On the other hand, with additional boxes, it gives higher objectness scores. Therefore, for a fair comparison, instead of objectness threshold, we fixed the false alarm rate to 2.4, which is original false alarm rate. Now we can compare the results. As you can see, the lowest hit rate is in temporarily consistent missing boxes. But considering half of the annotations are lost, we can say it is expected. On the other hand, can you look at the shifted boxes with 10% variance, please? This is actually 10% of the width and height of the box. In this dataset, mean of width height values are around 30 pixels. So only 3 pixels of the variance causes hit rate to drop 87%. Therefore, in our opinion, shifted boxes are the biggest issue among all annotation errors, because human cannot differentiate these 3 pixels visually. So the rest of the work, we focused on correcting shifting boxes. So, to correct shifting boxes, we have proposed a conventional template matching solution. We have two assumptions. There are no missing or additional boxes, and there is no significant change for the object appearance in the consecutive frames. Let me explain our algorithm. Let CK be the object center of frame K. We firstly got the object template at frame K, which is centered at CK. Then we search the frame K+1 for object template centered in CK+1 using normalized cross-correlation. We already know original center position CK+1 from annotations. The difference gives us the displacement dk to k+1. Then we have done a reverse search to find dk+1 to k. If dk to k+1 and dk+1 to k values are consistent and correlation score is above a selected threshold, we record displacement value, otherwise we stop tracking. Again, if there is no object at frame k+1, we stop tracking. If we know corrected object template at frame k, then corrected object template at frame k plus n is obtained with this update. Normally, displacement values should have zero mean. However, there is a problem. Since all displacements are accumulated, errors are also accumulated and there is a drifting. We remove the trend of accumulative displacement to achieve a zero slope and zero mean. To be more specific, please have a look at following figures. On the left, you can see X shifts dk to k+1 values of one video frame by frame. Then in the middle one, you can see accumulative displacements, and the red slope shows the trend of accumulative shift. So we remove that trend, we get zero slope cumulative displacement on the right figure. Then we can directly use this displacement to define corrected annotations. In these frames, green box is on original annotation and the red box is the corrected one. As you can see, most of the time red box encapsulates the object better. You can see more in the following video. This algorithm is used in all 100 videos. Then checking with human eye, we see that in 66 of the videos, annotations got better. So we corrected them and left the rest with original annotations. Then YOLOv3 is trained with corrected dataset. When only training set is corrected, tracking accuracy and hit rate is increased. But when both training and validation set is corrected, these increases are more significant. We can say that network can generalize some of the annotation errors while training. However, validation set errors directly affects the results, hence we can say that especially the set we check the performance should not have any annotation errors. So, in conclusion, we can say that performance of YOLOv3 on anti-UAV dataset is relatively well, where works good in terms of hit and false alarm rates, but could be better with tracking accuracy. We can clearly say that all types of annotation errors degrade performance, but the most significant one is shifted boxes. These can be corrected with a semi-automated method. When we correct, the results got better. And finally, When we take intersection over union between the corrected annotations and original annotations, we get 86.4% tracking accuracy. We can deduce that an algorithm which has a generalization ability can reach a maximum of 86.4% tracking accuracy without memorizing. Thank you for listening. Have a nice day.